Now dealing with the sigma notation. So it says if we have this, determine the value of k. So you have the sum from p equal to 0 up to k of this 1/3 p plus 1 over 6. The sum should be equal to 20 and the sixth. So we want to determine the value of k. So in many cases in sigma notation, what we want to do is expand a little bit, like maybe about 3 terms usually would be sufficient. So what do I mean by that? So this sign, the sigma notation sign, that sign is essentially means the sum of, right? So there is a sum of certain terms from in this case p equal to 0 up to k of terms which are defined by 1 over 3 by p plus 1 over 6. So the sum of all of that from p equal to 0 up to k should give us this value. But for now, we will not deal with that value for now. So let's just expand this. Basically, we will get successive terms as we substitute p equal to 0 into this, and then we go to p equal to 1, substitute into this, p equal to 2, substitute into this. So the first term of our series, we will use p equal to 0 because that's the first number here. So the first term would be 1 over 3 by 0 in place of p here plus 1 over 6. That's the first term. So I'm just going to put it in brackets to make sure that we understand that this is the first term, the whole thing in those brackets. And then plus, because it's sum. We have this sigma notation, it's sum. So we say plus. And then the second term, from p equal to 0, we go to p equal to 1. So then we substitute 1 here where there's p. So it will be 1 over 3 by 1 plus 1 over 6. Plus, I will do the last one, which would be the third one. We have done p equal to 0. We have done p equal to 1. Now we do p equal to 2. So I substitute 2 here. So it's 1 over 3 by 2 plus 1 over 6 plus on and on, right? We just want these 3. So what these 3 will tell us is what type of series is it. So that's why we kind of expand like this, so that we can tell what type of series is this. So 1/3 times 0, that's 0. 0 plus 1 over 6 is just 1 over 6. That's that. The first term is 1 over 6. Plus, here 1/3 times 1 is 1 over 3 plus 1 over 6. 1 over 3 plus 1 over 6 should give us half. Right, then the next term, if you say 1 over 3 times 2 plus 1 over 6, we would get 5 over 6 plus on and on. So now we want to use these 3 terms in order to find out what kind of series is it. Is it geometric? Is it arithmetic? So we can only find that out by trial and error. So I know that for geometric, for example, just as an example, if I say T2 divided by T1, it should be equal to T3 divided by T2. So if I divide term 2 divided by term 1, it should be equal to term 3 divided by term 2. That's the principle of the common ratio. If I know that for arithmetic, I know that it should be subtraction. So if I say t2 minus t1, it should be equal to t3 minus t2, right? So of course this is t1, t2, t3. So I have to test this. I can test this and see if it holds, if the t2 divided by t1 is equal to t3 divided by t2. If it does not hold, then that means I can try arithmetic to see if subtraction holds. If it holds, then it would be arithmetic. So let's quickly find that out. So if I say half divided by 1 over 6, okay, so that's the second term divided by the first term, it gives me a half multiplied by 6, so that would be 3. If I say the third term divided by the second term, that is 5 over 6 divided by half, this gives me 5 over 6 multiplied by 2, that is 10 over 6, which is 5 over 3. So we can see that it's not geometric, right? So geometric is out, right? So then we can try whether to see if it's arithmetic. So to see if it's arithmetic, then I do subtraction. I say what is let's say half minus 1 over 6. Half minus 1 over 6 is a third, 1 over 3. What is 5 over 6, which is the third term, minus the second term, minus half? Again, it gives me 1 over 3. So then that means I can see that this is an arithmetic series. Okay. So now that we have established that it's an arithmetic series using this sort of little experiment of ours, then we can move on now to the next thing. So with that in mind, why did we need to know whether it's geometric or arithmetic? Because let's go back to our question. It says the sum, because sigma means sum, the sum of a certain number of terms determined by p equal to 0 up to k. The sum of a certain number of terms is equal to this. So I am given a sum of terms, right? And I want to use that to find the value of k. So now that I know that it's arithmetic, it's an arithmetic series with common difference. It's an arithmetic series with a common difference of 1 over 3, which I found earlier, as we have seen. Then what essentially happens is that I use the sum to n terms of an arithmetic series. So I know that it's arithmetic with a common difference d of 1 over 3. So I want to apply the sum to n terms of an arithmetic series. Sum to n terms is equal to n over 2. I think this formula, you find it at the end of your question paper or somewhere in your material, plus n minus 1 by d. That is the formula for sum to n terms. And we already know, we are given that the sum of the terms is 20 and 1 over 6, like so. We're gonna convert that maybe to an improper fraction. So we want to go about a process which can help us to find what n is. Then with n, then we will be able to determine what k is. So we don't know what n is, so n over 2 by 2a. A is this first term of our series, this one, from the expansion that we did there. So that will be our a. That's 1 over 6 plus n minus 1. We don't know what n is, we want to find n, by d. D is a third. When we were testing to see whether it's arithmetic or geometric, we found the common difference was 1/3. And we know this sum should give us 20 and a sixth. If I convert 20 and 1 over 6 to an improper fraction, because I say 6 multiplied by 20, which is 120 plus 1. So 6 by 20, 120 plus 1, 121. So it will be 121 over 6. Now, I want to simplify things in the brackets here. So n over 2 by 2 times 1 over 6, that's 1 over 3. And here, 1 over 3 multiplied by n, that's plus, I can say n over 3. Right? 1 of n multiplied by 1 over 3 is n times 1 there. So n over 3 minus, say negative 1 multiplied by 1 over 3 is minus 1 over 3, equal to 121 over 6. Now, I can see that in the brackets here I have like terms. I have this 1 over 3 and this 1 over 3. So it's 1 over 3 minus 1 over 3. That's 0. So I will remain with n over 2 by n over 3, which will be equal to 121 over 6. And if I multiply here, it will be n times n, that's n squared. If I'm multiplying two fractions, I know it's numerator times numerator and denominator by denominator. So n times n squared, 2 times 3, that's 6, is equal to 121 over 6. I can get rid of the 6's, or I can just see that, okay, it's a fraction here and a fraction here with the same denominator, 6. So if the denominators are the same, 6, then the numerators should be also equal, right? Or I can multiply both sides by 6, whichever makes more sense to you. It's the same thing. So then cancels out here, then you remain n squared is equal to 121. So let's just continue like this. N squared is equal to 121. And if I want to find n and there is squared here, I have to take square root of both sides. Okay, square root of n squared, that's n, equal to square root of 121. You'll find that it's 11. So n is equal to 11, right? Now to finish, remember we want k, right? So basically what it means is if a series is like this, right, with first term this and second term this and third term this, and it's an arithmetic series, if a series is like this and you add 11 terms, then it should give you a sum of 20 and 1 over 6, right? Now, where are these 11 terms coming from? They are coming from, the first term came from p equal to 0. The second term comes from p equal to 1, right? And then the third term comes from p equal to 2. So we are working with, so let's just to illustrate, so to explain more here. So we had p equal to 0, that was the first one, and then we went p equal to 1, p equal to 2. Then if you keep going, p equal to 3, p equal to 4, for 11, to get 11 terms, right? To get 11 terms in our arithmetic, and you add that all up, you would get this sum. So then what would be k? What would be the k which gives us 11 terms? Now, because p equal to 0 is included, the 0 is included, then that means to get 11 terms, k would have to be 10, right? Because 0 is included. So from 1 to 10 is 10 terms, and then plus 1, that gives us the 11 terms we have here, right? So then if essentially what we are saying is that if n is equal to 11, then k has to be 10, so that our values here, our values there, so illustrate there, would be running from p equal to 0 all the way up to p equal to k, which will be equal to 10. So that 0 up to 10, that's 11 numbers, sorry, to give us the 11 terms. So if I count from 0 up to 10, including the 0, then that gives me 11 terms, which I need. So that's why k is equal to 10, like this.